Hi guys, so we didn't get to go through multiplication and division of integers last night in class, so I wanted to put together a little video for you to go through those ideas because you are going to be responsible for them on our next test, and because they're really good to know for teaching. That's really the primary reason. So let's jump in and get started. So multiplication of integers. Just like when we talked about whole numbers, right? We define multiplication as repeated addition. So 3 times 4, well, that means we need to add together 3 groups of 4, right? We can define that as repeatedly adding 4 groups of 4. So here we want 3 of them, so 4 plus 4 plus 4. We're going to just simply extend that idea to integers, okay? Only now we just have to take into account negatives. So this definition is extended to the integers by defining 3 times negative 4 as the repeated addition of negative, adding together groups of negative 4. So our first number always tells us the number of groups, and our second number tells us how many in each group. So for just like with 3 times positive 4, we had 3 groups, 1, 2, 3, of positive 4 being added together, right? 4 plus 4 plus 4. It's the same idea here. The first number tells us how many groups, so we need 3 groups, 1, 2, 3, and then our second number tells us what's inside each group. So we need 3 groups of negative 4 added together. So negative 4 plus negative 4 plus negative 4, that's going to give us negative 12. Okay, so it's the same idea. How do we do this? By using those colored counters. Okay, so again, we are going to think of our first number as our number of groups and our second number as how many is in each group. So if I wanted to show you 4 times 3 using colored counters, that means I have 4 groups. Okay, I'm putting together 4 groups because multiplication is repeated addition. Notice how my arrows are coming in because I'm putting these groups together. If they were going out, that would mean I would be repeatedly subtracting. That's division. But this is repeated addition because we're talking about multiplication. So my arrows are showing those groups coming in, coming together. So 4 groups of 3, right? My first number tells us the number of groups. I've got 1, 2, 3, 4 groups here. And my second number tells us how many in each group. I've got 3 positives in each group. So if I put that all together, I can count it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I get positive 12. I have 12 positive black little chips in there. Well, for 4 times negative 3, we still have 4 groups. They're coming together. But inside each group now I have a negative 3. So I need those red counters. And if I add them all up, I can see I have 12 red chips, which is negative 12. Okay? So we can see when we multiply together a positive and a positive, we wind up with a positive. And when we multiply together a positive and a negative, we wind up with a negative. Okay, now let's look at something a little bit different. What if we have negative 4 times positive 3, right? I told you before that that first number always stands for the number of groups, right? So we're still going to have 4 groups, but we read this as the negation of 4 groups of positive 3. So all we're going to do is we're going to start out, okay, with whatever this is telling us. All right, so if we look at our second number, whether it's positive or negative, we're going to start out by drawing our chip diagram as our second number stands, okay? So here I've got negative 4 times positive 3. So I'm still going to make my 4 groups, and I'm still going to include positive 3 in each group. But then I need to say, oh, now I need to negate it. So whatever I've drawn in here, I'm now going to draw a second diagram with the opposite, okay? So the negation means we need to flip or change the sign of what we've got. So I drew my 4 groups of positive 3, but then I'm like, oh, I've got this negative sign right here. So that means what I have in my picture, I need to now negate and do the opposite of. So I'm simply going to flip those black chips to red chips. So when you have a negative sign for your first factor, that means, okay, I'm going to start with what this is telling me in my groups. This is telling me I need 4 groups and positive 3 in each. But then that negative sign tells me negate everything that's in my groups. So if they were black, I now turn them red. Okay, so now let's look at the case where I've got a negative times a negative. So again, I'm still going to draw 4 groups. This is still telling me 4 groups. And I'm still going to start by making them negative in each group. So I've got my 4 groups. I've got my negative 3 in each group. Notice they're red chips because they're negative. But now I need to take into account, once I've drawn this, my initial diagram out, I need to take into account that negative sign, which means I need to flip and change the sign. So now my red chips become black. So I start with what it tells me. It tells me 4 groups, and it tells me to make those chips negative. So I need to make them red. But then I need to say to myself, okay, but my first factor had a negative sign in front of me, so whatever I have in this, I need to flip and make the opposite. So in the first example, my black became red, and in the second example, my red became black. Okay, so that's how we deal with a negative sign in our first factor, in our number of groups factor. Now, how do we deal with number lines? How do we show multiplication of integers on a number line? Positive times positive is pretty straightforward. So the first number is going to tell us the number of jumps. How many jumps am I taking? And the second number tells us the size of our jumps. Okay, so we've got number of jumps times size of jumps. So here I need to take 3 jumps of positive 4. And you should always read it to yourself just like that, right? Read it out loud like I just did. 3 jumps of positive 4, right? So my jumps I'm just going to do like I did in class. Because they're jumps of positive 4, I'm going to have a rightward facing arrowhead. And because multiplication means repeated addition, I'm going head to tail. So this is just like adding 3 jumps of positive 4. Okay, right? 4 plus 4 plus 4. I always start at 0 for my first jump. There's my first jump of positive 4. And again, this is multiplication, which means repeated addition, so I'm going head to tail for my next jump. There's my second jump of positive 4 and my third jump of positive 4. So that's 3 jumps of positive 4. Where did I land? I landed at 12. Okay, what about a positive times a negative? So here, we're still taking 3 jumps, but now we're taking 3 jumps of negative 4, which means my tail is going to be leftward facing, okay? This is still repeated addition, okay? So we are going to still go head to tail, okay? So let's take a look. And ignore where it says repeated subtraction here. This is still repeated addition. So here we've started at 0, and we've got 3 leftward jumps of negative 4. Where did I land? Negative 12, right? Notice again, multiplication is repeated addition, okay? So I'm going head to tail. Whenever we're adding on a number line, showing addition on a number line, we go head to tail. Those leftward jumps tell me that I was taking a jump of a negative integer, okay? And so I've started at 0, did my first jump of negative 4, my second jump of negative 4, my third jump of negative 4. I landed at negative 12, okay? All right, what if I now have that negative in my first factor, my jumps factor, okay? This is just like with when we were showing with counters, this is where it just gets a little bit trickier, but nothing crazy. So we read this as the deletion of 3 jumps of positive 4, okay? So just bear with me, okay? We are deleting. When I say deleting, what do I mean by that? I mean I'm going to place my arrows to the opposite side of 0 as I typically would. Okay, so I'm deleting 3 rightward jumps of 4. So watch what I do, okay? Because it's going to look kind of funny. I'm still taking positive, my jump size is still positive 4. It's still a positive integer. So my arrowhead needs to be rightward facing. Okay, this is still repeated addition, so I'm still going head to tail for my jumps. But typically when we would do this, let me make a little number line up here. Okay, so typically if this negative sign weren't here, right? If this were just 3 times positive 4, well, we know we'd start at 0 and we'd do our 3 jumps of 4. 4, here's my first jump of 4, here's my second jump of 4, here's my third jump of 4, and I would land at 12, right? We know that's how we would show 3 times 4. And notice how when we do that, because we're dealing with positive integers, right? We're going to the right of 0. We're going in the positive direction. Well, this negative sign right here is telling us, okay, well, you're still going to take those 3 positive jumps of 4, right? But because we have this negative sign, we need to place those jumps to the opposite side of 0, right? So typically, I would go to the right of 0. All I'm doing now when that negative sign gets involved is I'm taking those jumps and I'm literally like picking them up and moving them to the opposite side of 0. So now if they typically be in positive territory, now they're going to be in negative territory. Okay? And where we land, where the tail of our last jump lands, that's our answer, -12. So it's like we're picking up these positive jumps and we're just like moving them to the opposite side of 0 into this negative territory. We've had to move them to the left of 0 rather than to the right. Same thing if we have a negative, even if we're having a negative. So again, if I were showing 3 times -4, right? If we had our number line, okay, we'd always be starting at 0. I need 3 groups of -4, so I know that I'm going to have a leftward facing arrowhead, and I'm going to be going to the left of 0. So here's my first jump, my second jump of 4, and my third jump of 4, and I'm going to land at -12. Okay, so if we were doing 3 times -4, this is what our number line would look like. But now we want to do -3 times -4. Notice we've added a negative sign in front of that first factor. So again, we're going to be deleting, which just means pick this up and move it to the opposite side of 0. Okay, so we're going to pick these 3 leftward jumps up and we're literally going to move them into positive territory. Okay, so now it's going to look like this. We still have those leftward facing arrows because we still are dealing with a negative integer. So the size of our jumps is negative. We still need to have a leftward facing arrowhead for them. Okay, they're still going head to tail because we are still, multiplication is still sort of, repeated addition here. But now we need to go like the opposite way. So we're going to just, instead of placing them to the left of 0, we're going to place them to the right of 0. And here's where I land. Okay, so we're removing those 3 jumps of -4. We've got that removal going on, right? And we wind up at -12. These take some practice. So I recommend going into the resources on Blackboard. Okay, take out your station group work packet from last night and go through the station work. I've posted up on Blackboard by the PowerPoint and just play around with some of these because you really have to sort of think through it. Okay, rules for multiplication of integers. So anytime we multiply a positive by a negative, our product is negative, okay? Whether the positive comes first or second, it doesn't matter. If I'm multiplying a positive times a negative, regardless of the order, my product will always be negative. If I multiply 2 negatives together, those negative signs cancel and my product is positive. So give the video a pause and try some of this multiplication. And then once you've tried these out, and I mean really truly pause it because I'm going to show the answers in a minute, then press play again and you can take a look at the answers. So hopefully you've paused the video and actually tried these. Here's the answers, okay? So our 2 negative signs cancel and I wind up with a positive product. Here we have a negative times a positive, so my product will be negative. And here we have a positive times a negative, so my product is still negative. It doesn't matter if the negative comes first or second. If I'm multiplying together a positive and a negative, my product will be negative. Okay, here are the properties of integers. Pause the video, go through them. None of these should come as any surprise to you, but you really should take the time to at least read through them, make sure you understand them because this is telling you how integers behave when you multiply them together. Division of integers, okay. All this formal definition says is that division is the inverse of multiplication. Okay, so let's take a look at some stuff about how we can show division of integers to our students. So we can use fact families for these. So if we have m and n as positive integers, so that negative m and negative n are negative integers, and we suppose that n divides m. Then we say the following are true. M divided by negative n. Okay, so if we divide by a negative, our quotient will still be negative. If we start with a negative and divide by a positive, our quotient's going to be negative. And if we have a negative integer divided by a negative integer, okay, and they divide evenly, then we'll have a positive quotient. This is just like the rules of multiplication, right? Exactly the same. A negative times a positive gives you a negative. A negative divided by a positive gives you a negative. A positive times a negative gives you a negative. A positive divided by a negative gives you a negative. And if we have a negative being multiplied by another negative, they cancel out and you get a positive. Same thing here. If we have a negative being divided by another negative, the negative signs cancel and we're left with a positive. Okay, so you want to practice these. Really, truly pause the video and then come back in a minute to try them on to check your answers. So hopefully you've really, truly paused it and tried these out on your own. It takes all of 2 seconds. Here are the answers. So again, 2 negatives cancel and we're left with a positive. A positive divided by a negative, we're going to be left with a negative. A negative divided by a positive, we're going to be left with a negative. And then a positive divided by a positive will give us a positive. We can show multiplication of integers, or excuse me, we can show multiplication and division of integers by using these colored counter arrays. So think fact families, okay? For example, if I wanted to show the fact family of 1, 1, and 1, right, I could have positive 1 times positive 1 gives me positive 1. 1, negative 1, and negative 1, I have I have a positive being multiplied by a negative, so I'm left with a product of negative. Here I've got negative 1 times positive 1, so I'm left with negative 1. And here I've got negative 1 times negative 1, those negatives are going to cancel, and my answer is positive 1. Okay, here's a fact family, the fact family for 4, negative 3, and negative 12. So when I'm dealing with a fact family for multiplication and division, I should have 2 multiplication equations and 2 division equations, okay? And we can show them using these really nice fact family arrays. So my first factor is always represented along the bottom. My second factor is represented along the side. So if I'm doing positive 4 times negative 3, I've got my positive 4, my black counters going across the bottom. And then I've got my negative 3, my red counters going across the top. And that's going to give me, right, 4 times negative 3. We know that's negative 12. So here's my negative 12 chips inside. What if I want to show the fact family of, or excuse me, what if I want to show the other 2 equations? Okay, negative 3 times 4. So I've got my first number is negative 3, so my negative 3 chips on the bottom. My second factor is positive 4, here they are. And then of course, negative 3 times 4 gives us negative 12, so here's our chips inside. So here we've got the entire fact family, all equations showing the fact family for 4, negative 3, negative 12. Okay. I should have 2 multiplication. Here's 1, here's 2, and 2 division. Here's 1, here's 2. Okay? So due next week, you have your homework assignment in Pearson, your discussion assignment on grit. Oh, that's a real good one. And then your exit ticket I forgot to give you in class, so I'm posting it up in this announcement on Blackboard. Please reach out with any questions, especially when it comes to multiplication on, number lines. I know that can be confusing if you are starting with a negative factor. So please reach out if you have any questions, and I will see you guys next week. All right, bye.